Hello friends, welcome all to my series of lecture in radar engineering. In this series, we are going to study PRF and range ambiguities today. So what is PRF? PRF stands for pulse repetition frequency and is determined primarily by maximum range at which targets are expected. It is indicated as FP and FP is equal to C upon twice R un So RUM stands for R unambiguous. So and what is C? C stands for the velocity of light. So echo signals that arise at a time later than the pulse repetition period are known as a second time around echo. So when we are transmitting first pulse and when we are transmitting the second pulse. So in between the first and second pulse, if your signal, whatever the signal you are transmitted, if that signal reach to the target and comes back before the transmission of the second pulse, then that particular signal is called as a first time around echo. And when we are transmitting the second pulse and then second pulse and before transmitting the third pulse, if that signal arrives, that is echo signal back reflected from the target arrives, then that is called as a second time around echo. Then third, that is in between the pulse number 3 and 4, whatever the echoes that we are receiving for the same target, that is called as a third time around echo. So the echo signals that arrive at the time later than the pulse repetition period. Pulse repetition period means the time period in between the first and second pulse. That is repetition of the pulse. That is called as a second time around echo. उसके बाद जो भी है after that whatever is coming, that is called as a second time around echo. And after that whatever is coming, that is called as a third time around echoes, fourth time around echoes, or a multiple time around echoes. Now these echoes may cause a error. So these multiple echoes that we are receiving for the same target after the transmission of each pulse, for the transmission of each pulse, we are getting these multiple time around echoes, and that causes the error and confusion in the detection of the target. Also, it can mask unambiguous target echoes at a shorter ranges. So these are the problems which are taking place. So pulse Doppler radars have a usually problem of a range ambiguities because of PRF, that is due to this pulse repetition frequencies. Normally pulse Doppler radars are facing the problem of range ambiguity, that is finding out the distance for the target. Then uh, how this range ambiguities are occurring and how we can solve this problem, that can be seen in the next slides. Like for that, consider the three different target positions like A, B, and C. Now, target A is located within the maximum unambiguous range. That means whatever the echo reflected back from the target A, that will reach to the radar before the radar transmits second pulse. So that is called as a target A is located within the maximum unambiguous range that is shown in the figure. That is R unamp is equal to CTP divided by 2. What is TP? TP is the pulse repetition time, C is the velocity of light. So this A is located within the maximum or unambiguous range of the radar. Then if you observe the target B is in between the second and third pulse. So target B is at a distance greater than R unambiguous but less than twice R unambiguous. Okay, so target B is present at a distance greater than R unambiguous but less than twice R unambiguous. That is, it is present in between the whatever the echo that we are receiving from the target B, that is in between the second pulse and the third pulse. Similarly, target C is present a distance greater than the twice R unambiguous but less than the thrice R unambiguous. So target C, you can see that is present in between the third and fourth pulse. Okay, target C is present in between the third and fourth pulse. Okay, but you can see this in this diagram, that is we can see clear position of A in between the first and second pulse, that is in between the R unambiguous range. Then second and third pulse, in between second and third, we can observe the B, as well as we can observe the A dash. What is A dash? A dash is the second time around echo of A. That is when we are transmitting the second pulse also going to detect the target A. But that is fake detection, that is A dash, second time around echo detection, A dash. Then in between the third and fourth pulse, we can observe B dash. What is B dash? B dash is the second time around echo for the target B. Then we can observe the C, where is the C is a clear detection. And what is A double dash? That is the third time around echo of A. That is A double dash. Now see, if you observe these positions, A, B, and C, as well as A dash, B dash, A double dash. So you can clearly understand what is the actual echo and what is the time around, multiple time around echoes. Now see, if we give this signal to the A scope, then the display on A scope will be like this. You can observe B, which is very close to the pulse. Okay, so that will appear as the first. Then C, which is having little larger distance than B, that will the C. And what is A? A is having, in if you compare the distance in between the two pulses, A is near to the second pulse, so A will appear at the last. So you can observe the three targets on A scope like this. But what is that is out of this, when we are identifying the target, we have to find out which is the actual time around echo and which is the multiple time around echoes. So the ambiguous echoes are B and C, but they are looks very similar to the unambiguous echo A, that is the actual echo A. So out of these three echoes, only the range of A is correct and range of B and C are not correct. Then how to mitigate this problem or how to avoid this problem? So the ambiguous range echoes are recognized by changing the PRF of the radar. So for this, what we have to do, every time we are transmitting the pulse, new pulse, we have to change the pulse repeating frequency. That means we have to change the distance or time period between the two conjugate pulses. Whatever the time period in between 1 and 2, that should be, that same time period should not be there in between 2 and 3. That different time period. That means we have to change the frequency of the transmission of the pulses. So this we have to change for every transmission of pulses. Then what will happen? That is when the PRF is changed, unambiguous echo remains at the true range. That means unambiguous echo, that is A का echo जो है, that will remain at the true range and it will appear as a single echo or the single curve on the screen as shown in figure. But whatever the ambiguous echoes, that is echo B and C, they will appear at a different apparent ranges for each PRF, and you can see there are multiple curves at the position B and C. So wherever there are multiple curves, we can say that this range is not true, this is ambiguous target, and wherever is a single curve is there, you can say this range is correct one for that particular target. So in this way, we can reduce, by changing the PRF, we can reduce this ambiguities of the detection of a distance or the range of the target. So minimum 2 PRFs we need to transmit to detect the target. So correct range is same for 2 PRF. If the for both the PRF you can observe the correct range, that's then you can say it is unambiguous range. And if there are multiple curves are there, then you can say that is an unambiguous, that is ambiguous positions are there. So in this way, you can find out the range ambiguities, or you can reduce the range ambiguities by using different pulse repetition frequency.